Hi, in this video we want to discuss the cubic function. Now the cubic function has the following general formula where A describes the shape of the function just like with all the other functions that we've done. Now if A is greater than 0, our cubic function is a rising function, so it goes up, dips, and then goes back up. But if our A is less than 0, then our function primarily is heading in the downward direction. So it will go down, up for a while, and then back down again. Something like that. Now, this function has or can have at most 3 different x-intercepts. As we can see from the example, there is 1, 2, and 3. Now, this function, we can take the derivative of this function, and if we do, we get a function f prime x, which is the first derivative of f. Now the derivative of a function is basically another function that describes how the gradient of the original function changes as x changes. So from this we can see that in this first region over here, this function itself is decreasing, and for that reason we can see that our function that describes the gradient is also in the negative y region, and we know in this case the y-axis represents the gradient, so this represents the gradient of that function. The y values, when y is positive, we get positive gradient, and in this case this positive gradient here is described by this positive area up here, which is above the x-axis. So from the derivative of a cubic function, we get a parabolic function that describes the changing gradient of our cubic function. Then similarly, should we take again the derivative of the first derivative, what we get from that is this function, a straight line function which describes the changing gradient of this red graph over here, the gradient of the original function. So what information can this blue graph tell us? Well, if we equate the second derivative to 0, we are able to find what is called the point of inflection. So this is basically when concativity changes. If you follow this blue dotted line upwards, you get to the point where our graph changes from being this downward curving point to this upward curving point. By downward I mean this is concave down and this one is concave up, and the point where that concativity changes is the point of inflection, which is highlighted by the blue dot. So that is the information we can gather from the second derivative. The first derivative is also useful, as I've already mentioned, that it tells us what the gradient is at any given point on our original function. And we can see some critical points here. We see where the graph crosses the x-axis. Those points correspond to the turning points, because this is when the gradient is 0 or when y is 0, but we know in this function gradient equals y. Therefore the turning points of our cubic function correspond to the x-intercepts of its gradient function or first derivative. Then this is about it, and this is most of the knowledge you need to answer questions on cubic functions.